Okay. So when we talk about Chapter 5, I'd like to give you guys a bit of a preview so you know where we're going. So Chapter 5 is about, they're called rational numbers. We deal with rational numbers all the time. We just have never called them that. We're talking about rational numbers and then equations. All right, so basically what we're going to be doing is we are going to be going back to writing and solving equations, but we're going to be using fractions. So in this section, we're going to be doing quite a bit with fractions. All right, so this chapter is really all about fractions. All right, so let's first talk about what rational numbers are. Let's talk about what rational numbers are. How many of you guys ever heard that phrase, rational numbers? Did you guys learn about them last year? A little bit? All right, well, let's review them again because it's not something that on a regular basis that you deal with or that you talk about or that is that phrase, rational numbers. All right, so I'm going to do a diagram for you. All right, so we can talk a little bit more about what they are. All right, so what I want you guys to do is I want you to draw this circle. Don't make these too small because I'm going to have you guys right inside them. This circle are whole numbers. So give yourself space to draw some whole numbers in there. So whole numbers are like 1, 2, 3, 0 is one of them. 100. These are all whole numbers. All right, now I'm going to draw a bigger circle around this. Have we done this before? Okay. I'm going to draw a bigger circle. These are called integers. So integers are all of your whole numbers, your positive numbers, but they're also all of the negative numbers. So that's -1, -2, -5, -436. So it's all your positive numbers that are whole numbers and all your negative. What are missing in your whole numbers and your integers? Whole numbers and integers. What would you say they are not? What is missing? Because there are numbers that are missing that are not included in this group of numbers. Molly? Fractions. So this is, they are not fractions. What are they also not? Brendan? Decimals. They are not fractions. They are not decimals. All right, so now we're going to make this even bigger. And now the whole numbers and integers are all part of what are called rational numbers. So rational numbers So I'm going to kind of do a list next to it, but we're going to put some in here. Rational numbers are, they're whole numbers. God bless you. They are integers. I mean, integers are whole numbers, so our whole numbers are part of the integers. But what they also are is they are fractions. So that's 1/2, -2/5. And they are decimals. All right, but there are only certain there are only certain kinds of decimals. They're not all decimals. So they are terminating decimals. What does it mean if I say that a decimal is terminating? AJ? It ends. So give me an example of a terminating decimal. 1.5. So 1.5 is considered a rational number. Negative 0.62. That would be a rational number. All right, the other kind of decimal are non-terminating, repeating decimals. Non-terminating, repeating decimals. So an example of that might be 0.3 repeating. Now, the reason non-terminating repeating decimals, the reason they are considered rational numbers are they can be written as a fraction. So these, both of these types of decimals, they can be written in fraction form. That's why they are considered rational numbers. All right, what is 1.5 as a fraction? What is 1.5 as a fraction? Amanda? 3/2. What else can how else can I write that as a fraction? Ada? Well, isn't that 1 1/2? Wouldn't that also be it? Yeah? All right, what is 0.3 repeating as a fraction? You guys all should know this. What is 0.3 repeating as a fraction? Sophia? Pardon me? No, it's not 3/10. Because this is 0.3333333333. 0.3 without the repeating is 3/10. But I can't write that as 3/10. But I can write that as a fraction. What do I know that is the fraction of? AJ? That's 1/3. 0.3 repeating is 1/3. So if I take my calculator, just to prove it to you, 1/3 means 1 divided by 3. Anything with a 6 as a denominator, anything with a 9 as a denominator, usually are non-terminating, non-terminating repeating decimals. So if I have something like 7 divided by 6, that's also considered, that's a fraction, but it can be written as 1.16, and the 6 is repeating. Okay, so non-terminating repeating decimals, they can all be written as a fraction. All right, so if I was to put a definition to rational numbers, this is the definition I would write. Rational numbers. Any number that can be written as a fraction. So rational numbers are any numbers that can be written as a fraction. All right, so your question, I'm hoping, is, well, what other numbers are there? How many of you guys are thinking that? Like, what other kind of numbers are there? All right, so the other kind of numbers that we have are called irrational numbers. And we're not going to get into these today, but I want you to know that they're there so you will have something to compare it to. Irrational numbers. Irrational numbers are non-terminating, non-repeating decimals. So they are only one type of number, non-terminating, non-repeating decimals. So let me show you some examples. In math, in geometry, there's one example of this. One very distinct example of this in geometry. What's one number that you guys know the symbol for? That if you throw it in a calculator, it's a non-terminating, non-repeating decimal. Matthew? Pi. Pi is a non-terminating, non-repeating decimal. Let's see if I can do this. Can't remember if I can do this or not. So if I hit pi, I'm going to say equals. Mine only goes up to that number of digits, but it never stops. 3.14159. I've never had to memorize that because I don't really care. You know it, Molly?
I used to know 50. I don't remember.
That's awesome. Nope, I just remember 3.14. Because if you use it in math and you don't have a calculator, that's what you would use. All right, so pi is considered a non-terminating, non-repeating decimal. Another example are any non-perfect square roots. So if I take the square root of 5, well, 5 is not a perfect square. So if I type into my calculator square root of 5, I get a non-terminating, non-repeating decimal. All right, so non-perfect square roots. All right, so I don't want to ruminate too much on irrational numbers. We're going to deal with rational numbers. Okay. All right, so what I want you guys to do is I want us to write these numbers to prove that they can be written how you can write these as a fraction. So what I want you to do is I want you to show that the following numbers are rational by writing them as a fraction. All right, so here is my first one. All right, 7. How can I write 7 as a fraction? Danny? 7 over 1. Here's my second one. How about negative 10? How can I write that as a fraction? How can I write that as a fraction? Patrick, sit up, please, sweetheart. Amanda? Negative 10 over 1. Let's do my third one. How about 5 3/4? So I want to write it as a fraction. Let's be clear about this. I want to write it in the form a over b. This is a mixed number, but I want to write it in the form of a over b, so this would be an improper fraction. How do I turn that into the form a over b? Valentina? Excellent. So what would that be? What's 5 times 4? 23 over 4. All right. How about this one? Negative 3 1/2. All of you write that as a fraction a over b. Cullen, what would that be? Now drop the negative off to do it. And then when you're done, put the negative back on. Like when you're doing your math, drop off that negative sign. Okay? So what would this be? Excellent. Negative 7 over 2. Because when I first started teaching, I know that innately, right, that that's what you do. But there were a lot of students that would do 2 times negative 3 is negative 6, plus 1 is negative 5. Can you guys see how that mistake can be made? All right, and that's not what we want to do. You just drop the sign off, use the process in turning a mixed number into an improper fraction, and then throw the sign back on. Okay, how many of you guys are really cool with this? Awesome. All right, so what I want to talk about now is turning fractions into decimals. So we want to change fractions into decimals. All right, so if I gave you this, 3 3/8. What does this mean? Mathematically, what does this mean? Patrick? Yep, this means 3 divided by 8. All right, so to turn the fraction into a decimal, do the division. I want you to do this by hand. I want you to do the division. So what that means is my numerator goes inside the bracket, the denominator goes outside the bracket. Don't forget that. All right, I'm going to put my decimal point straight up. I'm going to put a couple zeros on there. All right, all of you do this division, please. How many of you guys got 0.375? Awesome. So 3/8 is equal to 0.375. Brendan. Okay, so when we have a story problem and we are dealing with it when it comes to a story problem, you're going to look and see what the data is. If it's money, you're going to go three decimal places and round out to the hundreds, right? If it's people, you're going to go to like the tenths and then round it up, right? Because it makes sense with people. So if it's a story problem, you're going to look and see what the data would require. You know what I mean? There's no reason to go up 5 decimal places when you're dealing with a number of people. Like, that would be silly. All right. On these, so the ones that we're going to be doing, if you take it out 3 decimal places and you don't see a repeating part starting, and you look and you see like, okay, I'm not going to get, and you look forward. Like here we saw that it was going to end in 0. We knew that with 4, we're going to bring the 0 down, we were done. If that was like a 3, and we brought that 0 down, and you're like, okay, so that's going to be 3, that's going to go back up, I might see a repeating part. I'll start with the repeating part again. If you see after like the 3rd or 4th one that it's not stopping, just stop. Does that make sense? Okay. All right, let's do another one. What kind of decimal is this called? What kind of decimal is this called? Well, you've got 3 choices because there's only 3 kinds. There's terminating decimals, there's non-terminating repeating decimals, there's non-terminating, non-repeating decimals. Which one is this and why? Sarah? Why? Yeah, it ends. I stopped with 40 here. I probably should have kept going and said 5 times 40. 5 times 8 is 40, and my remainder is 0. So terminating means that when we do the division, we end up with a remainder of 0. So division ends with no remainder. So that's what a terminating, technically, that's what a terminating means, is that when you do the division, we end with no remainder, or the remainder is 0. All right, let me give you another one. Who needs to see what's up there? Okay. So I want you to change this into this fraction into a decimal. So 5/11ths. All of you do that, please. Please do not use your calculators. Remember, it's always your numerator divided by your denominator. So if your numerator is bigger than your denominator, you're still going to do your numerator divided by your denominator. Don't forget. Alright, so I'm going to put a 0 dot here. I'm going to put a couple zeros on there. Somebody do this division for me. Addie, go ahead. Yeah, how many of you guys noticed that once you got to this point, you're going to get a repeating? Okay, so Addie, once you get to this point, and we see here that we're going to get a repeating, we can simply stop and put that line over top of that. So all of you, once you recognize it's going to start repeating, just stop. Don't spend any more time on it. If you can see that pattern starting, and just put a little line over it. You guys cool so far? How many of you guys remember, have you guys done this before? Kind of? Awesome. Okay. So what I want you to do is I want you guys to do this problem. This is example 3 from page 222, if you're someone that likes to look at that. Page 222, example number 3. So I'm going to show this to you. I want you to write down this information. And then we'll talk about it after you've written it down. Okay, so let's talk a little bit about how we're going to attack this. Which has greater fraction of rodentia? That's just a really sweet way of saying a rodent. Alright, so we want to know which has a greater fraction. Alright, so here's the deal. How do we have to start this? How are we going to start this? We want to compare what the fraction of mammals from one and the fraction of mammals from the other. So what's my first step in doing this problem? Ada? Yep, I need to turn them into fractions. How many of you guys are cool with that? Okay, so let's do that first. All right, so I'm just going to show you what I'm doing here. So what would the fraction of rodentia be for our Canyonlands? Our Canyonland Park. What would be our fraction for our rodentia? Sophia? 20 over 50. All right. How about for our Badlands? What would be the fraction? Molly? 24 over 54. All right, so let's make a note here. For us to know which fraction is bigger, all right, we have two choices. All right, so I'm going to say to determine which is greater, we have two choices. One is we need to write fractions with same denominator. Or, what else could we do? Think about what we're just working on today. What else could we do instead of changing those into fractions with the same denominator? What's our other option? AJ? Yeah, change them both to decimal. That's what I want you guys doing. All right, when you're doing this process, simplify both fractions first and then do the division. Life's going to be a lot easier. All right, so simplify both first, then divide. All right, all of you do that, please. So I'm going to flip my page because I don't have room here. So this first one simplifies to 2/5. Second one, they're both divisible by 6, right? That ends up being 4/9. Did I do that right? All right. So 2/5, I got 0.4. How many of you guys got 0.4? Awesome. Now, I've said this before. Typically, when 9 is your denominator, it's going to be repeating. How many of you guys are noticing that? 3s, 9s, 6s, most of the time, those are repeating. If not all the time, I always hate to say all, but I'm pretty sure it's all. All right, so this is going to divide. What did you guys get when you divided 4 by 9? Valentina? So 0.4, so it's 0.4. So the 4 repeats. All right, so this is equal to 0.4 repeating. Which one of these, so this is our Canyonland, and this is our Badlands. Which one is greater? Matthew? The Badlands. How many of you guys are cool with this? Okay. There's one last thing I want to show you, and we want to talk about, we want to change decimals into fractions. And today we're going to focus on terminating decimals. All right, so let's do an example just so we understand. So let's do 0.7. What place value is that 7 in? What place value? Alex? That's our tenths. So we're simply going to do 7 over 10. And then we simplify fraction if possible. I'm hoping you're like, yeah, I know how to do all this. This is super easy. Awesome. All right, let's do another one. So -3 .05. What place value is that 5 in? What place value is that 5 in, Danny? That's in the hundredth spot. All right, so when I write this, I have -3. Somebody write that .05 as a fraction. Colin? No, see, I have a -3. Write that .05 as a fraction. 5 out of 100. So we drop the decimal, we drop any of those zeros before or after it, all right, and we simply put that number, that 5 over 100, and then simplify. What would 3 and 5 100ths be simplified? Sophia? Yep, -3 and 1/20th. You guys cool with this? Not so bad, huh? All right, tomorrow I'm going to teach you how to change non-terminating repeating decimals, and that has a little bit of a process that's a little harder. All right, Patrick. No, I'm all right with you just kind of doing this. Does that make sense? Yeah, I know that's very incongruent to what I normally do, like showing all your work, but that's just, oh well, I don't know what to say. Yes? What? No, we're leaving it as a mixed number. Yep, so those that we have a whole, an integer part to it, a part on the left-hand side of the decimal, we're going to write those as the integer part. We're using a mixed number. Yep. All right, you guys can go.